Okay, so this last video is just over a couple random things. First thing is trig derivatives. You know how to take the derivatives of all these polynomials as long as they're in the toy train system. Okay, but trig derivatives, the two I'm going to teach you today are sine x and cosine x, and we're going to try and figure out what those derivatives are. Okay. All right, so let's see. I quickly drew sine x and cosine x on the board here. It's not drawn perfectly, especially that sine x looks a little funky. Okay, what are all of the steps I'm going by? Am I counting left and right by ones, by twos, by pi's, by pi over twos, by pi over fours? What am I counting by? This is 0, this is 2 pi, there's pi, 3 pi over 2, pi over 2. Okay, now, because we just talked about horizontal tangents, there are some points that you should know for sure. Horizontal tangents are here, here, there, and there. And this is going to be a little weird for you. I'm actually going to graph those guys on the grid. Okay? So, right here where you said it was 0, I'm going to plot that point 0. Right, no, let me extend it and do it down low so it confuses you less. Okay, so if I'm going to try and graph the derivative function, that if this is 0 here, I'm going to put a 0 there, and since this is 0 there, I'm going to draw that down to here and say this is 0. And I have one here. And I have one here where it's flat there, horizontal tangents. We'll move those dots to here and to there. Okay? Now, let's look. Everywhere here, the slope is positive, 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 positive. But where is it the most positive? Right there. And the least positive is here. And I'll just give you a little hint. The least positive is really small, but the biggest positive is only worth a 1. Okay? Just trust me on that. So if I need the biggest positives at 1, that's right here. That's where it's the steepest. I'm going to pull that guy down. So let's see. Ooh, right here, if it extended, that would be the biggest positive. And this would be the biggest positive up, because it's going up, up, up. So both of those would fall down on 1 and on 1. So likewise, what do you think here when I go here? It's negative, 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 and it gets less and less negative. Again, we're talking about slope. What do you think this slope right here is going to be? If the steepest up was 1, what do you think the steepest down would be? The steepest down would be negative 1. Okay, and basically I need to somehow connect those dots. So let's see what this would maybe look like if I connected those dots. So the top guy is f of x, and here's f prime of x, and the top guy was sine. What's it look like the derivative of sine is? What does the blue guy look like? Cosine. Yeah, so let's go back up here and say, if f of x is sine of x, f prime of x equals cosine of x. Super important guy to know. Okay? So, what's your prediction then if I give you f of x equals cosine of x? Yep, I know that's what you would want to say. You would want to assume that it's going to be sine of x. Well, let's take a look. Okay, I want you to feel good about it when you plot it. So again, I'm going to go down here. I'm going to try and line up the ticks. Okay, what are all of these blue dots worth? Slope-wise. Slope-wise, all those blue dots are flat. So I'm going to pull those down to 0. Okay? And then I taught you some more dots here. Going up, because it's going up there. What are those dots worth? 1. I'll put in tick marks here for 1 and -1. And then these dots here are steep, very steep, and they're going down. So they are -1 and -1. So now let me try and connect these. So this is f prime of x. Now, stare at it. Does it look like sine? Does it start in the middle? Yes, it is sine. But sine starts in the middle and goes what direction normally? Sine goes normally up, but this time I'm going down. So what is this guy really? It's not just sine x, it's negative sine x. Okay? So, the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. Okay? You might have a couple homework problems tonight that might look something like this. This will be, hey, here's f of x, which is x cubed plus, let's say, the 6th square root of x plus 2 sine x plus 5 cosine x. And it wants the derivative. Okay? So take derivative. Okay? Well, one thing I would do is all of these look good except this guy I would rewrite as x to the 1/6. Okay? Just because I like to see it as an exponent. Now you can take the derivative and nothing changes. 3x squared plus 1/6 x to the -5/6 plus. Okay, the derivative of sine, what did we say it was? The derivative of sine was cosine. So this would be 2 cosines. And the derivative of cosine, we just said, was negative sine. So 5 cosine would turn into -5 sine. Okay? You did it. The only thing I would do is I would change this little piece and say this is 1/6x to the 5/6. Just because, again, I don't like negatives in my exponent. And then you could say, obviously, everything else stays the same. Okay? So, that is the formula. For the 2 trig guys, sine and cosine, later in life, you're going to have to know about tangent, secant, cosecant, cotangent, those. But for right now, if you can just do the sine and cosine, you're good. Okay? So, with that done, I want us to go back to the worksheet I gave you. Okay? And the worksheet I gave you has this huge problem about Mount Isosceles. And I made this problem up, so I think I'm pretty clever, so I'm going to read it to you. Mount Isosceles is 1,600 feet tall. It is the highest mountain in the land of triangles. An apple is dropped off the peak of the mountain. Sokotoa, a famous archer, is going to shoot an arrow straight down at an initial velocity of -336 feet per second. He wants the arrow to pierce the apple right when it hits the ground. Oh my, this seems intense. This seems like it should be part of an action film. Sokotoa, your hero. Okay, so let's take a look at this. The key to these equations about free falling, and I don't know if I recovered this yesterday or not, because yesterday is Thursday, but I'm recording this lecture on Tuesday, which is kind of like a time warp. But the equation for free-falling objects is here, okay? That negative 16t squared, that takes into account gravity, okay? Anytime you see v naught, that's your initial velocity, and h naught is your initial height. Okay? So initial velocity, initial height. Okay? And this only works if it's a free-falling problem. Okay? So, free-falling apples height. Let's see. I always start with the negative 16t squared. Initial velocity of the apple. Let's see. An apple is dropped. So if I just drop the apple, there is no initial velocity. So I'd say plus 0t, because I just drop it. And my height is 1600. Okay? So do I really need the 0t? No. So if you want, you could say this is negative 16t squared plus 1600. Okay? And now the next question says, when will the apple hit the ground? Okay? Well, when you hit the ground, what equals 0 at the ground? The height. So height equals 0. So you can say 0 equals negative 16t squared plus 1600. So 16t squared equals 1600. T squared equals 100. Square root of that, t equals plus or minus 10. Now, it's a real world problem. When does that really happen then? 10 seconds. You can't happen negative 10 seconds ago. That would be into the past. Okay? So, that takes into account the height of the apple, everything we did with that apple. Now it says, write an equation for the arrow. Okay, so for the arrow, you still start negative 16t squared. Initial velocity of 336. Why is it negative? Because you shot it down. Velocity is different than speed. Velocity is, it gives you that direction of up or down as well. So it's a negative 336t, and it's still from that 1600. Okay? So now it says, when will the arrow hit the ground? Well, same thing, height equals 0. You're supposed to solve that somehow. And somehow it factors. And I'll tell you it factors because of that little hint that I told you. So let's see. If I say that hint, let me pull out negative 16. I got t squared. Take a negative 16 out of a negative 336 gives you a positive 21 left. Take a negative 16 out of 1600 gives you a negative 100 left. And this is supposed to factor. So what times what equals 100 that adds to 21? And think of coins. T plus 25, t minus 4. So my answers are negative 25 seconds, which makes no sense, or 4 seconds. Okay? Notice, none of this is calculus right now. I have not taken a derivative. The only thing I wanted you to get used to is this formula, and I'll describe it more next week if I haven't already, which is the equation of a free-falling object. Okay, so the next part says, how many seconds after the apples drop should I shoot my arrow? Well, 10 minus 4 equals 6 seconds. Okay. If you're curious why it's still a free-falling object, by the way, yes, I threw the arrow down, but once I threw it down, am I still pushing it the rest of the way? Is it like a rocket ship or like a car or anything like that, that you're still putting the pedal to the metal and... No. Right when you throw it down, It's no one's touching it anymore, so it is free falling after it was shot. Okay, now finally, when it talks about speed here, that means take a derivative. Okay, so the whole thing here is how fast is the apple when it hits the ground. Okay, so big note for you is this. If you start with height, and I want to talk about velocity or speed, the whole thing is you can take a derivative. The whole reason is this. Height is in terms of feet. When you take a derivative, you're finding what? Think about this. If height was, let's see, here's h of t. It's all about time and feet when you graph it. If you take slopes, and that's what slopes are, you take any sort of slope, what's your slope worth? Rise over run. So that is velocity. Okay? So let's take a look at this. So my height equation of the apple was negative 16 t squared plus 1600. And I need to take the derivative, which is negative 32t, and that's it. So I just went from the black to the blue. So I went from feet to feet per second. And it says when the apple hit the ground. The apple hit the ground at 10 seconds, which is negative 320 feet per second. Okay? So that's how fast the apple was going when it hit the ground. And the arrow when it started, initial of the arrow was negative 336. So the arrow was faster. And you would have to make sense with that, because if the arrow wasn't faster to start, it would never catch up. Okay? The big part here is the idea of this. This is the calc part. If I plot height in terms of time, so feet over time, feet in terms of time, the slope of all of those are feet over time, which is feet over seconds, which is your slope, which is your velocity. Okay? Here's the last problem of the day. Okay, I just want us to try out. Okay, and it gives you this. I have a rocket ship. Please be quiet, guys. Thanks. I have a rocket ship, okay? And it's on the ground, and I'm going to shoot it up. And I want it to hit the ceiling, okay? So I have a rocket ship on the ground, and it's going to shoot up and hit a ceiling that's at 5 feet tall, okay? And the question is, when does it hit the ceiling? And how fast when I hit. Now, is a rocket ship quiet? Is a rocket ship free falling? Like the apple or in the arrow? No. Because when it shoots off, oh, it fell apart. Whoops. When I shoot that rocket ship, it's still getting propelled by the gas. So it's not free falling. It's actually like a car on a road. It's driving. Okay, driving into the air. So, if I need to do that, let's see. When does it hit the ceiling? Is this a question about height or derivatives? When it hits the ceiling. Well, the ceiling this time is at 5 feet, so it's at h of t needs to equal 5. So I got 5 equals t squared plus 4t. This is not calc, this is algebra. So I got t squared plus 4t minus 5 equals 0. T plus 5, t minus 1 equals 0. So it either hit the ceiling at negative 5 seconds, which makes no sense, or 1 second, which makes a lot of sense. Okay? So it hit the ceiling at 1 second, and now it wants to know how fast was it going when it hit the ceiling. When I say fast, you need to think speed, which needs you to think derivative. Okay? So, if I had my initial guy for height was t squared plus 4t, I want to go to my derivative, which gives me speed, which is 2t plus 4. And if I plug in 1 second, because that's when it hit the ceiling, it looks like I was going 6. And what would the units be? Feet per second. And I might have forgot to tell you, h of t is in terms of feet with the t being seconds. If I tell you that, then you know the units of the velocity are feet per second. Okay? I kind of went through these two quickly, but I just wanted to show you these are previews of application problems, which we're really going to dive into on Monday with derivatives. Remember, the derivative helps you find slope, and if you start with a height function, that slope is velocity. So, here's your homework, and have a good weekend. Be safe at homecoming, and I will see you on Monday. So I think you'll have about 30 minutes, maybe 20 minutes in class that you can start working on this.